Yeah. Thank you. Great.
So today, I'm going to share with you my battle against legacy. And the story starts late 2014. I was working on a Laravel 4.2 project, and that was all fine. That was great. And then every year would pass, and I'd still be working on this Laravel 4.2 project, and I could see all the incredible things that were happening in the PHP world, all the amazing things happening to PHP in the language, and I kind of wanted to be in it, but I was stuck on this 4.2 world, kind of felt like I was walking backwards. And after many years, eventually we persuaded the client I was working with that it was time for an upgrade. And in autumn 2022, we started planning the upgrade, and then into 2023, we started doing it. And then finally, in February 2023, on the 24th of Feb, we finally made our 4.2 to 9 live, and was super excited. Finally done this massive migration. We were back in modern technology again. And the Laravel team were also pretty excited, so they upgraded Laravel from 9 to 10, and I felt like I'm coming back again into the past. But this is my story about how I went from Laravel 4.2 to 9, and maybe you also have, maybe some of you are working on old legacy stuff now, and you're thinking about how best to upgrade it. So although my story was Laravel 4.2 to 9, I'm presenting kind of ideas that will probably be applicable to wherever you are if you are doing some kind of, if you're working on some kind of legacy system that you want to upgrade. So this is what I'm going to be talking about today. Excuse me. And the first step in this process was what I'm calling code prehab, code prehabilitation. And my partner is a surgeon, and sometimes before she does some operations, she gives the patients prehab to do. So maybe that's changing lifestyle, or maybe it's exercises. And the reason for that is because it increases the chance of a successful operation, and it decreases the chance of any kind of mishaps. And the same is true with code. If we're going to go from miles in the past to present day, we would do well to get our code into a good state, ready for that transition from really old to new. So there's three things I did as part of the code prehab. The first thing was we'd kind of been operating on this particular project almost in startup mode for 7-8 years, and our code base was awash with just failed ideas and things that we didn't need anymore, code that was just not going to be used. So there was quite a lot of rubbish in there, and there was no point taking all that rubbish and upgrading it from 4.2 to 9. So we realized this quite early on, and we needed to get a handle of what code was or wasn't used currently. And we used something called tombstones. So what we did is every single public and protected method, we added this line of code, tombstone reporter trigger, and we would pass as a parameter the name of the class and the method. And we didn't actually go around and manually add all of this in. We used a tool called Rector, which I'm going to introduce to you in a bit, and we used that tool to automatically add this to all of our code. And what Trigger would do, Trigger would look in the database and says, has this been triggered before? And if it hasn't, it would say, by the way, this has now been triggered. So in our database, we would have a table of all of the tombstones that had been triggered. And then what we would do is we would get people to use the system. Initially, we actually put this on a staging environment, and we got one of the sales teams to go through their sales demo, and that triggered a load of the tombstones. And then what you could do is you could run a script, and it would get a list of the triggered tombstones in a JSON file. And then we would again use another script using this tool called Rector, which we'll meet later. And it would go through, and any of the methods that have been called that were in the triggered tombstone.json, if it found the tombstone trigger in the code, it would remove it automatically. So what would happen is after a couple of months, we had a pretty good idea what functionality was being used and what wasn't. And of course, we could have had a guess at what's used, but this kind of really shows us what people are using in the code. And then what we did is we went through all the places where we still had this tombstone reports trigger called. We just grepped through the code for that. And then we would decide, is this code that we still need? So for example, there was some code which did quarterly reporting, and we hadn't run quarterly reporting while the tombstone bit was running. So obviously that code hadn't been triggered. So we then went around and we started removing the code that wasn't used. So each bit where there's a tombstone trigger, we look at it and we go, actually, you know what? I don't think we need that anymore. Oh, that was that feature that we don't use anymore. And rather than just deleting it all in one big commit, what we actually did was we deleted it in chunks. So for example, we might delete something to do all with a product listing page, and that would be a single git commit. Maybe there's another bit for some old pricing logic which we don't use, and again, that would all be removed in a single git commit. And that means if in the future we did think, oh, you know what, we want that functionality back, it was easy to find it through we could at least find out what the code was like. So that was our first step of code prehab, get rid of all the junk that we don't use anymore. It's a bit like when you're moving house. There's no point taking all that stuff you haven't used since you last moved, so just get rid of it. The next thing we wanted to do was we wanted to increase our type coverage. So if we look at this code here, we might be able to guess at what some of the types are, but we don't really know what $users is. Okay, we could, in the context of this code, we could guess that it's some kind of iterable. And yes, we could probably look at this method and work out it returns a string. But if we look at the method signature, we have no idea what this returns, and we have no idea the types of $user or $users. If we contrast this to this code, this has got 100% type coverage. If we look at the getNames function, we can see that it returns a string. We can see that $users is an array. And where we don't have the ability in the language, we can, in the dot blocks, give the additional information. So we can say this is an array where the keys are ints and the values are user. And why is that so important? Well, imagine as part of our upgrade, we're going to change the getUser method to getUsername in our user class. If we look at our first example, I can see there is a getUser method, but is that one that we can change? We don't know for sure, okay? So maybe a software developer who's intimate with the code, they might go through and go, oh yeah, that's definitely going to be something of type user, so this is one that we want to change. But we certainly can't do it safely in an automated fashion. There might be other methods called getUser that we don't want to update as part of this change, so we can't just do a global search and replace on text. Whereas if we look at our 100% coverage, we know that the $user we're iterating through from the dot block is of type user, so we know that this getUser method call does need updating to getUsername. So we can do this completely automated. And the other benefit of having 100% type coverage is every single one of these kind of refactors we can do safely. We don't actually need any test coverage at all, because we know if we have 100% type coverage and all of the types are correct, we can just go and make these changes, and if the code worked before, it will still work now. That said, you still do need tests. On our particular project, we had quite good test coverage. We probably maybe covered off 60 or 70% of the use cases of users using it. It was mainly an API, so we were covering off a lot of those use cases in automated testing, and that helped us massively. And if you haven't got any tests, then doing these kind of upgrades from 4.2 to 9, or any kind of big upgrade, is going to be a bit more problematic. But let's say you don't have any tests. Probably the best thing to do is add some tests, and probably your biggest bang for your buck is to add something called smoke tests. And a smoke test is just something where you call the API endpoints, or if it's a web application, you kind of browse to all the pages, and you're just making sure that you essentially get an HTTP 200. And it doesn't crash. There's no 500s or anything like that. And so we don't really care what's on the page. We don't really care what's coming back from the API, but it's just a way of exercising all of your control of endpoints, if assuming it's some kind of web application or API. And it's just giving us some level of confidence that after we've made all the changes, at least something is still returning, you know. And of course, these can be the foundations for building more and more tests if you want them. So if you have no tests, I would think about adding smoke tests, at the very least. So this is our code prehab stage. Oops. So there's 3 things we did. We removed all the dead code, we increased our type coverage, and we were okay on test coverage, but if you don't have great test coverage, then think about increasing your test coverage. So then the next stage of it was to plan things out. And the first thing we did was, let's look at what tools are out there which might help us with the upgrade. So if you're using Laravel, you might have heard of Laravel Shift. That is a service that helps you upgrade from one version of Laravel to the next. There's also a tool called Rector, and this is an incredible tool. We're going to talk more about it. And this helps you with refactoring and with upgrades. And of course, maybe there's going to be bits of manual work as well, and maybe you'll be writing some scripts, or maybe other people have provided scripts to help with upgrades. For example, the Symfony Flex scripts can help you with upgrading your Symfony project. Our first port of call was Laravel Shift. And we had been working on this project for maybe 7-8 years as a 4.2 project. And we'd taken lots of kind of twists and turns, and there was a stage where we thought maybe we're going to move it to Symfony, and then we decided against. So by the time we got to this bit where we wanted to go from 4.2 to 9, we weren't really dealing with what would be a normal Laravel 4.2 project. So we did try Shift on it, and it didn't work, but that's not Shift's fault. That's our fault because we've gone so far, of course, from what would be a normal Laravel project. But if you're working on a Laravel project and you're kind of going with the Symfony way of working, this will probably do all you need to do. So unfortunately, it didn't work for us, but there was this other tool called Rector. And Rector, it's quite configurable. It has a number of rules that can help you alter your code. And you can also create your own custom rules. And we're going to look later at how you can do that with an example. So at the time I created this slide, there were 359 rules. But if you look on the website now, there might be a few more. And one of the rules they have is called the rename method rector. So that allows you to rename a method name from one name to the other. And it has lots of other rules. We've got one that can convert your code into early returns. So that's just to show you just how clever some of the code modifications can be. So if we want to use Rector, first thing we do is we install it. And then if we run Rector for the first time, it will say, you don't have a rector.php config file. Do you want me to create it? And we say yes, and then it goes and creates a config file. And this is an example of a config file where it just does one rule. What we do is we have to tell it where our code is. So I've said here all our code is in source. And then here I've got with configured rule. So I'm using the rename method rector. And the rename method rector also takes a list of any of the renames you want to do. So here we've just got a single rename we're going to do. We're going to update the model class where the method belongs to is going to become belongs. This is just an example. So if I had that rector and I ran it over my code, I recommend the first time you run it, you put it in dry run so you can see what it's about to do. It'll show you the diff for that. But if we ran it, so this is a screenshot from it. Don't know how clear that is, but here we're in class model, and it's actually updating the name of the method from belongs to belongs. So this is diff format. The plus in red is the line we're removing, and the minus in the red is the line we're removing, and the plus in the green is the line we're adding. So it used to be belongs to this method, and now it is belongs. And Rector also goes through and looks at all the places where we were calling belongs to on a model, and it's updated it to belongs. And you might say, well, that's all very well, but I can do that in my IDE. And you'd be right. And this is where rule sets come in. So rule sets are just a collection of Rector rules. In Rector itself, it has a whole series of rule sets to upgrade PHP from one version to the next. And there are repositories out there. For example, there's rectors for updating your Symfony version, and there's rectors for updating your Laravel version. And if we wanted to run a rule set, our config would look a bit like this. And instead of with configured rule, we've now got with sets. And this is the Laravel to take you from Laravel 8 to Laravel 9. So we've got a rule set. And if we go and look inside what one of these rule sets is, it's just a whole series of rules. So maybe, this is a bit from the Laravel 9 upgrade documents. It's saying we're going to convert with Swift message to with Symfony message. That was part of the update from Laravel 8 to Laravel 9. And if we go and look inside the Laravel 9 rule set rector, we can see at around line 80, we've got a method rename where we're going from Swift message to with Symfony message. So that's the benefit. What happens is somebody can work out what all the changes are required, they can codify it in a rector rule set, and then they can share that. So anyone can take that rector rule set, run rector on their code base, and it will do the code changes required, providing, of course, your code base has got high enough type coverage for it to know, for rectors to know what's going on. And even with these tools, you might still have some manual bits to do, some manual work, and maybe you're going to script things as well. So these are some of the ways that we can take our code from where it was to where we want it to be. And the next step is to make a plan. So we can make a plan by reading the upgrade documents. Symfony has also got quite a nice way of doing upgrades for major versions. What you can do in Symfony, if you want to go from, like, say, 5 to 6, you would upgrade to 5.4, which would be Symfony's highest minor version. You can then run your code and look at all the deprecations that it throws. And you can make a list of all those deprecations, and that is all the stuff you need to clear up. And once all those deprecations go away, it is safe to migrate your code from 5.4 to 6 in this example. And then you'd run the flex recipes. Now, if you have a really good test suite that covers a lot of the functionality of your code, then you can just run your tests and collect all the deprecation warnings and work out what is required. Even if you don't use Symfony, it is worth reading how the Symfony do their major version upgrades, because I think it is a really good way of doing these things. In my particular project, we were going from 4.2 to 9. Rightly or wrongly, we decided we're not going to go through every single step. So instead, what I did was I looked at how Symfony 9 worked, and then I made a list of all the things that I would need to change from our old code over there. So I made a checklist. So however you make your checklist of all the things you need to do, we need to have a list of, like at least a list of high-level tasks that we need to do in order to do this upgrade. And then with each task, you're kind of asking ourselves, can we automate it? If we can't, it's going to be a manual task. If we could automate it, is there an existing solution? Maybe is there an existing rector rule set to help us automate? If there is, note that, so we've got that. And if there isn't an existing solution, then you have to ask the question, is it worth my time in writing something to automate this? And the answer largely depends on many things. How many times in your code base do you see this thing that you need to upgrade? And generally, the larger the code base, and the more times there is this pattern that you need to upgrade, the greater the chance that automating it will make sense. So you go through your list of tasks and go, right, this is what I've got to do manually, this is what I've got to do automatically. Now, a big mistake that I made in our upgrade from 4.2 to 9 is I just did it pretty much all as just one chunk of work. So we had development, and then it stopped for 3 or 4 weeks while we did all the upgrade, and then development could continue once we'd upgraded. And part of the reason for that was because there were so many moving parts, and we thought we can't really let people continue to do bug fixes or add new features, because it won't really be obvious where the code is, because all of the code was moving around. So it was just easier to say, well, let's stop any development, we'll do the upgrade, and then we'll start development again. But it would be better, generally, to divide this big task into smaller tasks? Well, it would be, actually that sort of depends on your system. If you have really good CI and you've got really good automated tests and you have a simple release process, if you're in the stage where I can update my code, I put it into CI, the CI says green, and then I release my code, and generally it always works, then I would recommend trying to break down your big upgrades into smaller tasks. And this is something I think, in retrospect, is what I should have done. So how can we break this up? I mean, this is just an example. Let's imagine we have our fictitious framework at version 12, and we're currently running PHP 8.1 and PHP Unit 8. What we're looking for is, are there ways we can break that up? Because we've got to update the framework, we've got to update PHP, and we've got to update PHP Unit. And in this example, we can see our current supported version uses PHP 9, and so does the new version of PHP Unit, also uses PHP Unit 9. There's a common version of PHP as well. So instead of doing it in one go, maybe we can break it up. So the first thing we do is upgrade PHP Unit, then we upgrade PHP to 8.2, and then we upgrade our framework. And, well, okay, there's no point releasing a PHP Unit update because that won't affect real users. But we could put the PHP 8.2 and any of those bits live, leave them live for a bit, make sure everything's okay, make sure we don't get any bug snag or sentry alerts, and then we can work on the upgrade. So rather than having a big thing to do, if we can divide it into sections, that is probably a better way of doing big upgrades. So mine, in a way, was quite difficult because we were having to upgrade PHP versions by 2 or 3 PHP versions. We were upgrading from 4.2 to 9 on the Laravel thing. So there wasn't really that many common bits that we could have done to break it down. Except, well, actually there were. Now, I don't know if anyone's done Laravel 4.2, it's pretty old, but back then, everything was just in the global namespace. But actually, we could have moved everything to the namespaces they would have been in for Laravel 9, and it could still have worked in Laravel 4.2. We'd have had to tweak a few bits. So perhaps that would have been a good first step, take the code, put what we can in the positions where they would be in the Laravel 9 way, but still running on Laravel 4.2. That probably would have been possible. The other mistake I made is I started writing the automation scripts kind of as we went into this code freeze. But what I could have done is started writing the automation scripts just while other development was still ongoing. And then once I was happy with all those, then we would do the upgrade, and that would be the section where, okay, probably we need everyone to stop working on active development because everything is getting moved around so much. But that section would have been smaller because I already would have had the scripts ready to go, and then this would just be doing any manual checks and manual updates and testing. So our plan stage, look at what tools might be out there to help with whatever framework you're working on. Make a list of all of the things you need to do, work out how you're going to do those, and then, if at all possible, try and break the task down into smaller sections. So then we went into the execute phase, and that is pretty much just following the plan. But here are a couple of tips. I would say try and be systematic about things. I'm assuming there are some bits where you're going to be doing this manually. So, for example, I had to manually go through and update all the validation logic because that had changed quite significantly. And at the time, I thought it's just not going to be very easy to make my own vector rule to do this. But as I was going through the process of updating the validation logic, I might see other things that also needed updating. But I didn't want to get distracted by them. I just wanted to focus on this one task. So what I would do is if you start seeing other things that need to be updated, or just make a note of it, put it in a Trello card or whatever you use. Also, we did to do L9 and then a description of what needed to be done. And that's something we would grep for later to make sure we'd caught all the things that we needed to do. So here I am working on one task. If I see something else, I'll document the fact that it needs to be done, but I won't go off and do that. I'll stick on the task that I'm doing. And that means it's also easier to hand over tasks as well. So I can say, I'm still working on this, and actually I've just seen this needs to be doing, so maybe someone else can work on that. I'd probably also make heavy use of Git, even if you later squash these things down. So this just acts, if you start going down one way and you suddenly realize you've done it all wrong, you've kind of got like an undo method, if you want, with your Git commits. Another thing that's really important is just fix what you need to do, okay, to get it to the next version. So if you use Rector to go from one version of PHP to the next, what it might do, what it actually does if you use the custom Rector rule sets, is at the moment, it will take advantage of all the new language features. So for example, suppose you're going up to whichever version of PHP introduced constructor promotion. I think it was 8, but anyway, whatever version of PHP that was. Just because constructor promotion is now available doesn't mean you should actually use it. And there's a lot of benefits in saying, well, I'm just going to focus on the current way of doing things, and I'm just upgrading it. And yes, there are some nice-to-haves that I want to do later, but I'll do those after I've got this upgrade working. And one of the reasons is we're going to be changing a lot of code, and we don't really want to then have like refactors, like using constructor promotion in all there. If we ever have to go through the diffs, the diffs are going to be even bigger if we have all of this extra stuff, all of these extra refactors that are not core to upgrading from wherever we were to wherever we want to be. So I think this is really key. Try and do the minimum to get you from where you are to where you need to be, and you can always do the extra bits afterwards, okay? So possibly we might have a stage where we've got to write our own custom Rector rule. This bit of the talk's quite heavy going. If I lose you on this bit, don't worry, come back for the thought bits afterwards. So there was one example of some code that I needed to update. So in Laravel, you use the belongs to say this entity is related to another entity. And in Laravel 4.2, everything was in the global namespace. So if you said car belongs to user, it was okay to use the string user because the class name was called user. It was in the global namespace. But after we moved, or when we moved to Laravel 9, all of the models are by default in app models. So we would have to take this code here, where belongs to user, and change it to belongs to app models user : class. So I knew I needed that to be done, and there was no custom rule I could find that would do that at the time. So I noted this down as something I wanted to do. And then the other thing is you then need to think about, is there other scenarios where the code looks similar, but I don't want to make a change? So some of our code, we had used the user : class, even though back then it was all in the same namespace. So maybe that wasn't technically necessary. But if I had code like this, then I didn't want this Rector rule to update that. And also, if I had some code which calls belongs to, but we're not calling belongs to on a model, then we also should leave this code as it is. So when I'm writing my own Rector rules for upgrading from one version to the next, I think about what I want to do, and I kind of think about all the other similar scenarios where maybe the code shouldn't change. And this is to help me, these help form the test fixtures for my Rector rule. So the next thing I do is I run Rector, and I say custom rule, and it says, what do you want your custom rule to be called? And it's called fix modern mappings Rector, and it goes and creates a whole load of files, including some test fixtures and a framework Rector for you to fill in the gaps. And if necessary, it'll update your composer.json file as well. So the first thing I'm going to do now is take the code snippets I showed you earlier and make them fixtures for the Rector rule that I'm about to do. So what I would do, when I've got code where I say, given this code, I run my Rector rule, and I expect the output to be this. I put the code beforehand, then you do 4 dashes, and then the code afterwards. And what that does is that tells the Rector test harness that, given that, run my Rector rule, I'm expecting this. For the code that doesn't change, I just put that in there. And because we haven't got the dashes and we haven't got an alternative version, this tells the Rector test harness that when I run my Rector rule, on this code, it shouldn't change. So I go and create my fixtures. So I made 3 fixtures based on the code that I've shown you. The next step is we need to provide an implementation for these 3 methods: get rule definition, get node types, and refactor. Now, the get rule definition is primarily there for documentation. So we return an instance rule definition. It has a description, in this case, fixed model mappings, and then you can provide 1 or more code samples. And the code samples show this is the code before, and this is the code after. So this is basically to help with documentation. So that's get rule definition. We now need to provide implementations for get node types and for refactor. But before we can do that, I just need to explain a bit about something called the abstract syntax tree. So when we run our code goes through several steps from the code we write to it being executed. So the first thing, it goes through a tokenizer stage. Then the tokens get converted into something called the abstract syntax tree. The abstract syntax tree gets converted into opcodes, and then the opcodes are run on the PHP virtual machine. And what we are interested in is the abstract syntax tree phase of this. So all PHP code can be represented in an abstract syntax tree. So an abstract syntax tree is a tree-like structure made of nodes, and we've got nodes of different types, and depending on the node type, depends what information we have about it. So we've got this code here. We've got a class, so that is a class abstract, a class node in the AST, and it's got some properties. It's got a name property, and that's an identifier saying this is name is car. And it also has an array of statements, and in this case, there are 2 high-level statements, the user and another method, and those are both of type class method. And if we drill down further into user, the function user is a class method type. And again, it's got a name as an identifier, and it's got some statements inside it. Now, there's this library called PHP Parser, and this has PHP representations of all the nodes you can find in the PHP abstract syntax tree. And we often interact with this when we're creating vector rules. And I think the key takeaway from the AST bit is that PHP code can be represented in this abstract syntax tree. There's lots of different nodes, and depending on the node, depends what information we have, what information we give. And what happens in Vector is it goes through the entire abstract syntax tree, and it says, I don't know, I've got a class node. Are there any Vector rules that are interested in class nodes? And some of them say, yeah, I'm interested in that. And Vector will pass to that Vector rule saying, here's a node. And then the refactor method will be run, and either the node will be updated or it will be left as it is. So it goes through the entire abstract syntax tree, and every single vector rule will be run on the nodes that it's interested in. So the code that we are trying to modify is this. This belongs to, with the string user, becomes this belongs to with app users and user : class. This construct in AST world is called a method call. So our vector rule is interested in method call nodes. So if we look at the method call node in the PHP parser library, we can see it's got 3 properties. It's got $var, which is the variable we're operating on. We've got $name, which is the name of the method we're calling. And we've got args, which are the arguments we're passing to this method call. So you should be able to see how all our code is represented in the abstract syntax tree, and also how the abstract syntax tree in PHP world is represented in the PHP parser library. So back to our custom vector rule. We've got a getNodes method. We're only interested in method call classes, so we just say we just return the method call. Those are the only ones we're interested in. And then finally, we need to provide an implementation for refactor. So refactor takes a node that is currently looking at in the abstract syntax tree, and it either returns null, which means we're not going to update it, or it returns an instance of node, which means that we want you to swap whatever node you passed in with this node that we are returning. So let's remind ourselves what we're trying to do here. We're looking for an instance where $this is an object that extends model, where the name of the method call is belongs to, and the first argument is of type string. And if all of those things are true, then we need to modify this bit of code in our code base. So let's look at all those 3 steps. The first thing is var an object that extends model. How we do that is we create something of object type based on the model, and then we use this method provided by Rector is object type. So we're saying is $node var something on model type. And if it isn't, we return null. And if it is, we'll continue on to the next bit. And then we're saying, is the node name thing, is it belongs to? If it isn't, we'll return null, so we're not going to modify this bit of code. And if it is belongs to, then we can continue. And then finally, we're saying, is the first argument a string? So arguments are a 0 index, so we're going to go node $arg0, and then we're going to say, is it of type arg? And if it isn't, we'll return null. And if it is, then we say, what is the value, what is the type of value of the argument? And if it's not of type string, then we're going to return null. So this means if we get all the way down here, we know this is code that we want to modify. And instead of returning, what we want to return is we want to modify the argument value to something called a class constant fetch. So user : class, that construct in AST world is called a class const fetch. The thing on the left-hand side is the object that we're operating on. So remember, everything used to be in the global namespace, so that's users, and we want to put it in the app models namespace, so it's app models user, so that's how we get our fully qualified class name. And then the thing on the other side of the double colon is just an identifier, it's : class. So this is our implementation for refactor. So this goes through our code and says, is this how it used to, is this code, this will manipulate the code if it meets all of these 3 things. So if we're acting on model, if the name we're calling is belongs to, and if the first argument is a string, we will modify our code. And if you want to see that in action, then I've got a GitHub repo there which has this demo Rector rule. And if you want to learn more about creating Rector rules, then this is a great book. It's written by the author of Rector, and it goes through how to create your own custom rules. And this is really powerful stuff. This allows us to create rules that can do quite powerful refactorings or updates on our code. So this is the main process I kind of went through. I did my code prehab. I removed some dead code. I increased our type and test coverage. Then we went through the planning stage. What rules can we use? What tools have we got? How can we break this down into a smaller thing, smaller tasks? And then the execution phase is we're just focusing on lots of small steps. And we just want to do the minimum to get us from where we were to where we are now. So I'd like to wrap up with a few thoughts. The first thing is, if we're creating software that's going to be around for a long, long time, it's really important to decouple things. So we want to decouple our business logic from everything else, from our framework and from any libraries that we might be using. And you might think, yeah, but my framework's amazing. And it does, if you're quite tightly coupled to the framework, you can do things super, super quick. But just think about whatever framework you're using and remember what it was like 10 years ago and think, would I want to be coupled to something like that? And hopefully in another 10 years' time, frameworks will be even better. So if you're in startup mode, then I can understand why we'd have high coupling between our business logic and our framework just to get things done. But if your code is becoming more established, then you need a kind of cleaner barrier between your framework and your business logic. And there's lots of ways of separating your framework from your business logic. There's hexagonal architecture, there's having a service layer, there's having kind of a message passing architecture. There's many architectural ways of achieving that. And the reason we want all of these things kept separate is because they all have their own different life cycles. Like business logic only really needs to update when business requirements change. The frameworks update based on whatever release cycle your particular framework has. The libraries, well, they update based on what they are. So maybe we are using a library that sends text messages. So ideally, our business logic just knows about this interface, this text message gateway. It says, I want you to send a text message from this number to this number, and here is the message. So this is all our business logic knows about. And then maybe one of these green libraries there is, I don't know, a Twilio text message sending library. So we've decoupled the Twilio text message sending library from the business logic. And if something happens, like Twilio upgrade their API version that requires a new version of the library, well, we just update that library there and the adapter from our interface to the Twilio adapter, and we're just updating a bit of code down here. So we're isolating all of the changes in the system. Now, there is that red library in the middle of business logic. Sometimes we will use a library. For example, suppose we're dealing with money, and we think, well, I don't really want to write all my own money code, so I'm going to use somebody else's money class. What happens there is we're tightly coupling that class to our business logic. So we've just got to go in open eyes. I'm not saying don't do it, but I'm just saying think about it. You know, who's maintaining this library? Is it just one person, or is it a team? If it's just one person, what happens in 5 or 6 years' time when they've given up PHP and they're not maintaining that library? Suddenly, that code becomes your problem. Okay? So absolutely use dependencies, use libraries to stop you having to rewrite them, but just think carefully about them, especially when you're coupling them to your business logic. It doesn't matter so much down here because we've got some kind of adapters, so if you need to change it, we can change it. But the ones that become integral to your business logic, we've just got to think carefully about. And then it's just kind of a final thought, really. Well, maybe I don't know, maybe someone over there, they are upgrading from framework version 1 to framework version 2. And they work out all of the scripts they need. They work out all of the PHP stand rector rules they need. And that's great. But, you know, maybe they document it on a blog. And maybe someone else is doing exactly the same upgrade. Wouldn't it be good if the person creating the framework could codify or could put what needs to be done, put those steps actually in somewhere, like maybe the composer.json file for their particular framework. So maybe we say, look, if I want to upgrade from version 1 to version 2 of my framework, maybe I'll go through this validation stage, which runs some scripts or runs some PHP stan custom rules to check the code really is in a state that it can be updated. And if all of these pass, well, look, here are kind of some scripts or some rector rules that you need to run. And then this is kind of a way of documenting what needs to be done. And then what would happen is you say to Composer, I want to upgrade my framework from version 1 to version 2. It might go and look at all the dependencies and say, hang on, this library needs to go from version 7 to version 8. And then it goes, but I've actually got some update details. So I know how to do it. I can just run all these scripts. And if they all pass, then I know I've upgraded that successfully, so then I can upgrade what you're doing. So I think that would be quite a cool thing. And the great thing about PHP is we have all of these tools in our ecosystem. We have all these tools in our toolbox. We have Rector is an incredible tool to allow us to do these kind of automated updates. So we've got all the building blocks. Perhaps we can put them all together. And then if we did that, a complicated upgrade wouldn't be weeks and weeks of work. It would just be a composer update command, something like this. Anyway, I've been Dave Liddament. Thank you for listening.
Thank you, Dave. This was very, very insightful. I really enjoyed that. Anyone has any questions?
How are you going to handle updates going forward? Are you going to wait another 10 years, or will you do it more incrementally?
We're going to be on top of it now. That said, we still haven't upgraded to Laravel 10 yet, but that looks much, much simpler. And because we've done a lot of the pain from that big update, we will upgrade. So normally we've got like a variety of projects we work on, and a lot of them are Symfony. And what generally works is a good time of year to do those to fit in with their release cycle, and actually would work with the Laravel release cycles as well, is to target doing them in kind of April time. So you've got the PHP updates, you've got the Symfony updates. Normally Laravel will do a new thing in Feb as well. So it gives a couple of months for it all to kind of settle in, and then someone else can iron out all the bugs, and then it just gets around to April and we just kind of bump everything up to the latest versions. And that is a much better way of doing things. But you might say how we're in a situation where we hadn't done any updates for 10 years, or 9 years, or whatever it was. And the reason was because at the time, it was very much in startup mode. We didn't know if that was really viable. In fact, there were some really hairy moments in there where I thought maybe this whole project's going to just fail. Not for tech reasons, but just trying to get it to market. So it is, yes, we as tech people think we should always be having the latest versions of stuff. We should always be keeping things up to date. But there are often real commercial pressures which prevent that from happening. So that's why that particular project had, kind of got into the state it was. But now it's turning over a lot of money every year, and we've kind of got the ability to kind of keep on top of these things. So yeah, it won't be another 10 years.
Do you have to agree with your clients when you're planning on doing those updates? Is that because presumably they're going to have to sort of pay for that work? Or?
Yeah, so the clients will pay for the work. So generally, it's about picking your timing for having these conversations. So if you're, I think it depends on what kind of company you're working for. But if you're kind of working in the startup world, and they're really worried as if it's viable or not, that is not the time to say we need to do a month of upgrade work, because they're clearly going to say no. But when things are looking good, that's when you can start saying, right, we need to think about this upgrade. And you can try and use things like, well, look, if we want to scale up the team, then it's going to be much easier for us to get developers if we're working on up-to-date tech rather than stuff from 10 years ago. So that's one thing we use to try and encourage the updates. The other thing is point out that everything's outside of security support now. So if we did get hacked, possibly you get in trouble from that respect as well. So I think when you're proposing work like this, you need to be aware where the company is financially. And if it's not good financially, this is not the time to have those conversations. But when things are looking good, that's when you have those conversations, because they'll be more likely to be receptive, and you have to sell it in kind of business benefits like up-to-date stuff, easy to get new developers, those kind of ways. So they probably don't care about the tech, so you've got to sell it in what might be beneficial to the business. Or that was my experience anyway.
Yeah, anyone else? So
Cool.
excellent talk, Matt says online here.
Good.
Really clear explanation of a programmatic approach to upgrading any project from a legacy version. Thanks, David Liddament.
Thank you.
Love Rector too. Good to see how easy it all add to your own rules.
Yeah, Rector is a fantastic tool, and it's really worth getting to know. Yeah. I'm happy to talk about any of this stuff, so if you've got any questions after this, come and find me, and happy to talk about it. But otherwise, thank you very much for your time.
Yes, give me another round of applause.